let's do this first. Yes, let's remove Dolores. Good morning, everybody. Welcome. My name is Pim van Baarsen. I'm CEO for the Sales and Technology Cluster. Welcome to our Digital and Advanced Manufacturing Special Interest Group event. So Niall is one of our champions for that group, and Niall will be guiding us through the day. So I'm just going to be here for a couple of seconds. Just a little bit of housekeeping in terms of how the platform works. So you should have on the right-hand side of your screen, you should have a little screen with question functionality and a chat functionality as well. So please, by all means, use that. Obviously, the Q&A functionality, please use that to type in any questions that you might have for the speakers, and then Niall can bring those to the speaker's attention. There should also be a functionality, I believe, at the bottom of your screen where you can raise your hand. I mean, I would suggest that you leave that until after the presentation, but if you are not very excited about typing in your question, then by all means press the raise your hand functionality, and then we can invite you onto the stage so you can ask your question in person. And I think there's also a little button with a little smiley face that brings up several emoticons. So if you like what you hear, then by all means sort of press those and show your appreciation that way. So that's effectively the housekeeping. I'll hand over to Niall now so he can guide us through the day. Niall, over to you.
Okay, well, thanks very much, Pim. Welcome to the event, everyone. I hope you can all hear me properly and you're getting all the images. We've got a pretty packed event for you this morning. We've got some very, very interesting speakers, and they're going to talk to you all about how to improve your business and practical ways you can improve your business and make your business better. And that's the whole thing about Industry 4.0 and digitalization and all sorts of things. Don't be put off by the terms. It's making you better, making you more efficient. So in the special interest group for digital and advanced manufacturing at the STC, there's, in addition to myself, there's Kieran Salter, who's the CEO of the Digital Manufacturing Centre. They're a very exciting new project at Silverstone itself. There's also Bradley McEwen of Beckhoff, James Reeves of Vauxhall Jet, and of course Brendan Shepherd of the Smart Factory in Ireland, who will be speaking later. And now I'm going to introduce Guy Brown shortly. He's our first speaker. He's from Renishaw in Gloucestershire. He's the Central Development Manager for Renishaw, and they're basically going to give us a practical on how to do it. It's how to do it guidance on Industry 4.0 metrology. So, Guy, can I actually bring you in, and would you like to carry on and do your presentation?
Thank you, Niall. I hope you can hear me.
I think we can all hear you.
That's all right, just checking. Okay, appreciate being first up. It's just making sure that the technology works. Please let me know when you can see my first slide. Oh. Can you see that? I'll take that as a yes. Okay, assuming you can see my screen. My name's Guy Brown. I'm a development manager at Renishaw. I've worked at Renishaw for over 30 years with a bit of a hiatus in between. It's a CNC program, well, taken straight out of university, sponsored through university, was a CNC programmer, then a CNC production manager, then became an operations manager, then left for a while to go and get into this heady world of Industry 4 before it was called Industry 4, where it was actually just collecting data from devices to do some analysis to work out what I needed to improve. And have since rejoined Renishaw back in about 3 years ago. But what I'm going to talk about is is industrial metrology in terms of Renishaw's experience of that. We've got over sort of 40 to 50 years of it, talking about the practical steps that we've taken over many years in terms of the evolving journey that we've taken to go and collect data from metrology devices and manufacturing machines, and how we've sort of evolved what it is that we need to measure with an understanding of control. It's basically very much about measure something with the intention of not just knowing if something is right or not, but actually knowing what I need to change to make it better in the future. So that's what I'll be going through. So just for those who don't know, I'll talk about sort of industrial metrology. So it is very much about measuring stuff and being able to benchmark it against some sort of standard. So at some point you need to have some traceability of what it is that I'm measuring. Does that compare to a known good standard so that I have trust and confidence in the measurement that I'm taking? Then being able to not just apply that metrology to the part, which is quite often the normal way of things, which is I have a part, I have a drawing, I have a specification, measure that specification, is it good or not, but also measuring the process that's producing that part. Because quite often the processes that we use aren't actually very part orientated. They're very machine orientated, very tooling orientated. So it's actually, well, let's measure that process that's producing that part. So again, I've got some idea of confidence and certainty, making sure that things are accurate and repeatable, traceable, and consistent. And unfortunately, words like confidence and consistency tend to be fairly woolly words. How do you know? But most importantly, what I really want to stress is what we've definitely evolved at Renishaw over a long period of time is the more precise that measurement is, and the quicker that you can feed that back in the form of control, the more efficiency, quality, and productivity you're going to get. And it's that feedback. It's all very well knowing if something is right or wrong, but if you can't do something about it in a timely manner, then you're not going to improve. Okay, so I will touch on sort of Industry 4. I do appreciate Industry 4 is this huge umbrella statement that promises an awful lot, but tends to be slightly trickier to actually implement. And there really isn't a silver bullet at this point in time to be able to sort of say, oh, well, I've bought Industry 4, I've implemented Industry 4. It doesn't work like that. Basically, it has to be a strategy of, well, how am I going to actually connect things together? How am I actually going to extract that data? A lot of the manufacturing processes that we have, certainly within the CNC machining industry, they're really goldfish. These machines that we're using kind of know what they're doing right now, and they might know what they've been doing over the last hour, but actually long term, they've got no idea. And actually, each time you produce a part, it really doesn't remember what it was what it did the last time it produced that part. So how do we connect these things up? And there's APIs and the standards, and even then, these are not fully evolved yet to be able to capture all of the information that you actually might need. Being able to store that, preferably in the form of not just raw data, but information, actually getting some contextual information against what it is that you are actually doing, not just some raw data points, and then making that visible using dashboards, sort of OEE dashboards on shop floors, etc. All of these things really help. Then being able to make it accessible. So we have a lot of people with a lot of experience who need to be able to have the right tools to be able to actually carry out the analysis on that. And that's going to ultimately then lead to the magic of AI, which again, it's an evolving landscape here. There is a lot of talk of machine learning and a lot of talk about AI as well, but there's relatively little in terms of sort of empirical evidence of where that's really being used on a grand scale to improve manufacturing processes at this point in time. So I'll talk about connectivity. So for those of you who are involved in sort of CNC machining in any shape, size, or form, you may have come across a couple of standards that tend to get used in terms of data connectivity. One is MT Connect, which was born out of the United States at the end of the noughties. It's currently at its version 1.7, and still from our perspective, there's no metrology in it at this point in time. So there is no ability to transport metrology information within that standard. It is planned in an upcoming release where another standard called the QIF standard will be adopted. But again, it's all very well having these standards. As and when they're released doesn't necessarily mean that they're instantly accessible to anybody. It's just a standard. It is literally just something that has been put onto a form and a piece of paper, and it's then catch up for the people who adopt these standards and with their tooling to then adopt that within the tooling. Coming out of Germany at this point in time is another standard called UMATI, which is based on a technology called OPC-UA. And again, from a metrology perspective, all it has in there is a per part evaluation in terms of, is it good, is it bad, is it suspect, or is it not being measured yet, or is it not being measured at all? Nothing about the actual metrology, the actual measurements that have been taken in there. So there are other, so what we end up doing is sort of falling back to other areas to be able to give us the metrology information using native APIs, things like called MQTT brokers, REST APIs, etc. But it does need collaboration. And this is the real point of Industry 4 is we can talk about the technology, but there's going to have to be collaborative effort between solution providers, the consumers, and the integrators. And that is the biggest journey of all. Just getting connectivity is a journey in itself. And it is therefore, it's the responsibility of us, and I think of Renishaw as very much a data provider, to work with the data consumers and the sort of standard creators to make sure that these standards keep evolving. Okay, so how do you start your Industry 4 journey? And it has to be about the people. Ultimately, we can talk about technologies, we can talk about software and other things, but it has to have people at the top of it who have a top-down vision of how am I going to actually implement this, and recognize that I can't just necessarily go to a company and buy a solution that's going to solve all of my problems. It's going to have people, and it has to be a cultural decision to move through with that. Where possible, basically saying, okay, asking the question of, well, what sources of data do I have, and how do I match that to the existing knowledge and expertise that I've got? Making sure that, as I said, top down and engineering and IT. I mean, a lot of these discussions that you end up having with people tend to be IT discussions. Cloud platforms are all over the place, but actually getting people with the confidence and the psychology to say, blimey, am I going to want to store my drawings, my metrology information? Am I really going to want to put that in the cloud? It's not happening right now. It will do in the future, but right now there is still a psychological barrier against doing that. Focus on actionable data. Again, measuring something is very useful, but actually what you really want to work out is, well, what is it that what action am I going to take? And let that lead you to then work out, well, what is it I need to measure accordingly? Doing something well rather than everything badly. Again, there tends to be a culture of sort of, well, let's just collect everything. Let's collect all of our data and stick it into a data lake, and we'll build up 5 years worth of data, and then we'll work out what we're going to do with it. That's a great approach long term, but actually it would be better to actually sort of work out with some low hanging fruit. Let's just go and collect one thing or a number of things from a number of different areas where, because we know what the action is that we want to take, that's what we're going to focus on. It is about these small incremental gains that will require the long haul. So at Renishaw, over many years, we've sort of built up what we call the process pyramid. Well, we've basically sort of very much tried to compartmentalize what it takes to get a good good process in place, which is very much about understanding the machine that I'm using or the device that I'm using, is it fit for purpose? And my first slide I sort of touched on, traceability. Calibration is very important. Being able to understand periodically as to whether or not the equipment that I'm using is capable of doing the job that I expect it to do, and being able to proactively take out some calibration or health data from that device is very important. You then focusing on, okay, I've got a machine that I know can produce what it's doing, but somewhere there has to be a process that's actually going to make the thing that I'm making, and I need to implement some checks within that so that I've set the process up correctly, and actually I am also periodically checking that that process is doing what it's supposed to be doing. That is then going to create an output, which in most cases will be a part, and then the post-process monitoring side of it will then check, well, was the output of that machine and that process fit for purpose? But it's all about these woolly words that I used at the beginning: confidence and consistency. So within Renishaw, we very much carried out a fairly large scale Ishikawa diagram in terms of sort of going, okay, let's go through everything. Let's go through everything that we think that we need to focus on. And one of the two areas that I'm going to touch on is the machine itself and the tooling that's used on the machine. But there are loads of different areas that you could focus on. And this is what I'm saying, trying to do everything is going to be a challenge. So maybe start in a couple of areas. So how do I know if my machine is fit for purpose? So within Renishaw, we have an associate company called MSP, who have some software that they use that is called the NC Checker, and this carries out a very thorough evaluation of the probe itself, so of the Renishaw device, to go, well, actually, is the Renishaw device calibrated, and is it repeatable? Is it doing what it's supposed to? When I take it out of the spindle and put it back in again, is it still okay? How is the machine performing over time? Does it drift? Because everything changes. There's always going to be temperature variation. There's always going to be wear going on the machine, etc. And very much also focusing on and as soon as you've got into 5-axis machining, the more axes you put on there, the exponentially harder it is to control what's going on that machine at any point in time. So carrying out some basic checks is very useful. Also at Renishaw, we designed our own core alignment checks. So that's our 4th axis that's going onto the machine, where we carry out some checks, and we also make sure that we thermally compensate what's going on the machine relative to the measurements that I've just taken. So I'm going to show a small video. So I'm not sure if you can hear the noise. It's noisier than I expected. This is where we're doing this core alignment check, where we're literally coming in and measuring an artifact which has been calibrated offline. We're doing some rotary axis checks just to check if the rotary axis is repeatable, not just in one direction, but in the other direction as well. So we're literally tracking a point in time and seeing, is that point the same as where it was previously? And then also here we're checking the actual full turnover of the particular 4th axis. That was a lot noisier than I thought it was going to be. I'm not sure if you could hear that. So the point of that is that particular health check we implement every time we make a part and every time we run a process, because it has an impact. Knowing where that rotary axis is absolutely critical. When we're making a part, we're looking at this part going, okay, I know I've got a key dimension here that I need to hold, and that is this face relative to the center of this bore. That is a function of the work offsets, and it is a function of the rotary axis of the machine. So therefore, if I'm to hold plus or minus 100 microns, this is about what do I need to control? Is that rotary axis good enough and repeatable enough to give me, to enable me to hold that? Can I then make sure that my work offsets and the tool offsets that I'm using, which are things that machines are using, are good enough to hold it? So what we're also doing is some long-term measurement as a result. Sorry, just excuse me a minute. Sorry about that. Yes, well, we carry out some long-term measurement on this. So what we've been doing is every time we've measured this core alignment, we actually log what's been going on. So over 8 years, we can start to build up a picture of one machine relative to another machine. So while we're sort of seeing, the absolute position of this on one machine has not moved very much over time, we can see on another machine it has moved in several areas, and there's a couple of different areas here where it's moved quite a lot, which is basically inherent machine instability. We can then break that down into, okay, but what was the incremental variation? What does that actually mean? So in this particular area here, the actual incremental repeatability of it is well under 50 microns, which is great when we're talking about trying to hold plus or minus 100 microns. Whereas on this second machine, actually, it's quite often predominantly greater than 50 microns, which means we've used up quite a lot of our part tolerance already on this particular machine tool. We can also see the particular periods here where actually it's just not been capable at all. But it is this long-term picture of not what's it like now, but actually, is this machine fit for purpose? We can then categorize that in terms of a histogram to go, okay, how many occasions did it actually exceed these different, this 50 micron tolerance, and by how much? And again, you're building up a picture of the machine, one machine relative to another machine, so you can start to choose, right, I can try and carry out a load of maintenance on this particular machine, but actually, if I look back, it's been like this for 8 years. Is that machine the ideal machine for this part, or do I need to basically try and suit the part to the machine that I'm using? The process itself, so tooling issues. Okay, so inspection of parts will only ever measure the finished part. The part itself is created by a number of different tools, and a lot of those tools won't actually be visible on the part that you've actually produced. So roughing tools, for instance, are used to hog out an awful lot of material, but they're quite often never represented on the finished part that you happen to be measuring. So being able to understand and look at things like swarf control, the depth of cut, tool wear, etc., of these roughing tools is just as critical, if not more critical, than the finishing tools. So using the probe in cycle on the machine helps us to understand what is that roughing tool doing at any point in time. And as a result, we can basically sort of sit there and go, okay, if we control the roughing tool, we're ensuring that when the finishing tool comes in, it's taking the same amount of material. Consistency. It is making the same amount of material every time. So I've got a better idea of, by controlling the roughing, I can control the finishing better as well. Also looking at critical dimensions. You don't have to, on a machine tool, measure every single feature that's created from a part perspective. It's very much looking at those, the tooling perspective, and going, okay, what are the critical dimensions I need to control for tool length and diameter? Because these are the things that the operators of the machine are actually adjusting. The machine tool has no idea about the features that it's producing, and it has no idea about the tolerances of the features it's producing. It just knows that I have work offsets, tool offsets, diameter offsets, rotary offsets. Those are what get adjusted. So what we do is we basically very much make sure that we baseline everything. So there's a literally just setting the tools and letting the tools do its thing with no control whatsoever allows you to run a batch to sort of understand, well, what is the inherent variation that I'm establishing as a result? You could then go to post-process monitoring, which is, okay, I've set the tools, I'm going to measure the part afterwards. It could be quite some time afterwards. And the longer the time it is, the less you have the ability to influence the process right now. So therefore, it's passive control, but that will invoke some sort of level of control. Or we can do active control, which is actually measuring the part or measuring the tools, or the features created by the tools at the point in which they're produced, and actually adaptively updating those offsets accordingly, quite often with something like a slight offset correction of, say, 75% to dampen down the amount of adjustment that I'm making. Adjusting constantly to where you are right now is not necessarily a healthy thing. Again, remember, a machine tool is a goldfish, doesn't really remember what it's done previously, but by collecting that information and then basing those adjustments based on a length of period of time actually helps you to guide a process back into being control. And the impact of that on your capability can be quite significant. So when we were talking about process setting only, when we were working on a particular feature, we get a CPK of about 0.32. When we introduce post-process monitoring to that, it does improve the CPK and it does reduce the amount of scrap and rework accordingly, but not as much as if we do the active in-process control. As I put in my original slide, the closer that you can get the metrology and the feedback to the process into your solution, the better it's going to be. So something that we also do is we introduce slave features into this. So what we're doing is, rather than actually machining the part to completion and then measuring it, by which time it may be too late, we actually use areas on the part where which will be machined away. So they're sacrificial features, basically. But we pick on each of these, and for each tool, we basically machine something that is representative of what we're going to do. But it's also simple to measure. So rather than focusing on difficult things to measure that might take difficult stylus configurations, which means that it's quite hard and it's quite expensive, we make it simple. We make the method of measuring simple. But that allows us to go in and measure these features and then update the tool. It can be seen as lost cycle time. We don't do it on every single part. We will do it sort of periodically during a batch of parts. So we actually do it sort of every first off, but this is a collaborative effort. And again, when we're talking about Industry 4, this is all about collaboration of people as well as technologies. So designers, engineering teams, and the quality function talk to each other about, well, what am I trying to control? And let's design these sacrificial features that I will ensure that then controls the process accordingly. And the tolerances that we put on these are then relative to the overall tolerances that I'm trying to hold on the part. This is a part-specific set of features, but in certain cases we have generic ones where we will literally just take a piece of almost scrap material and use that, and that may be then used for a family of parts, not an individual part. So this one is relative to this individual part, but quite often we will do something that actually suits a family of parts where we're using the same tooling suite each time. So what we can do from that is basically then look at the long-term history of what the adjustments were, and what we very quickly found out was things like spot drills, for instance. If I set at the spot drill, it isn't necessarily set to the point of contact that you're actually trying to control relative to the part. So you end up with experience values that you end up putting back into your G-code program, so that rather than setting the tool and actually expecting the first one to be wrong, you've already taken that data capture over a period of time to basically say, actually, do you know what? If I add in an experience value, that part will be right because I've already got the history of it. Sometimes it's not possible to do this on the machine tool itself, so we use an equator system with something called intelligent process control. We're taking the measurement off the machine, we're mapping that part measurement or the feature measurement to the tool offset update, and then we feed it back to the machine accordingly. And again, I've got a video for this. So where it is sometimes more challenging to go and fit the probe onto the machine tool itself to take in the in-process control measurement, using automation, using robot systems, etc., we can then load this onto an inline equator system, which is then measuring those features. As I said, they are then mapped to what tool offset do I need to adjust and by how much. And we implement additional tolerance bands. So it's not part tolerance bands. We're using process capability to work out, well, what's the adjustment? How much does it have to be? And then we keep a traceable record of that. So it's not done on every component, but it's able to guide the tool in line. Okay, so to sort of cover on this, so on the Industry 4 side, this is about how do you start your journey? How do you work out what it is that you want to start capturing? the key is it's about trying to unlock this potential of your manufacturing processes. It's thinking in terms of what data do I need to capture because it's actionable, because over long term it's going to tell me whether my machine is fit for purpose. In the shorter term, it's going to help the machine to understand what does it need to adjust to make sure that the parts are right. So we're thinking parts, processes, machines, control. And as I said, things like the slave features, think outside the box. Think of other ways that you'll be able to capture that measurement information that you need. It doesn't have to always come from the part. But most importantly, this has to be top down. It has to be a cultural thing, and it has to be done with consideration and with collaboration, both locally between different disciplines, and when you're working with different companies and different suppliers, whether or not they are hardware or software solution suppliers, there should be an expectation of collaboration between those also. As soon as possible. I mean, as I showed you, we've been actually collecting data for 30 years off these machines. So as a result, we know how one machine, even though they are in essence exactly the same machine type and exactly the same age, they can perform differently. So the sooner you're collecting something, the greater the benefits will be long term. Thank you.
Much.
Hello.
Yeah,
you want to find out I've spent the last 20 minutes talking to myself.
No, that was absolutely fascinating. Thank you very much, Guy. I worked 10 years ago. I was working with Renault Formula One in Viry-Châtillon, and I wish we'd had this sort of technology and the concept of the collaboration and making sure that the systems were intertwined and worked together, because we had so many sort of, oh my God, I've got to rush off to Paris because we've measured something and they've measured something and we're a micron out. Yep. That's so simple. I mean, I've just been keeping my eye open to see if there are any questions. I mean, I've got one, and that is, can you help with your customers when they take on your systems? Can you help with the personal collaboration? Can you come in and advise when one of your customers says, one of my customers isn't happy with what I've got, I'm sure it's okay. How are we going to work this?
I absolutely agree. And I think this is, for me, it is one of the key aspects of Industry 4. It's like I said, I put a slide in there about people and collaboration because it has to be about the service as well. Anybody who is providing an Industry 4 platform is going to have to ensure that they are providing the service and the support that goes with that platform. It's not just about the software. It is very much about the applications effort that goes with it. And I think that is sort of the transformative side of what industry is going to expect in the future. When you look at mobile phone platforms, you look at Microsoft, you look at all of these platforms that are trying to, that are moving from sort of the traditional, buy a software, you get on with it, and every now and again you can upgrade. It's about the service. It's not about the software per se. It's actually about the service and the support that you get to solve your problems. And that is actually the big thing that Industry 4 needs is understanding, yes, we've got some really clever technology, but you can't separate it from the people. The people are absolutely integral into this, and it's their experience to help customers with their Industry 4 solutions. There's a lot of work goes on at a government level with Made Smarter schemes, which is all about helping pilot schemes, which isn't software specific. It's about skills. It's about upskilling the workforce to be able to talk to each other at a level that is revolving around connectivity and data and so on and so forth. That's the biggest challenge.
Yeah, I'm very pleased to hear it. As a specialist in making the relationships between people right, I suppose that's where my job is. It's nice to know that we're still useful.
Yes, absolutely.
Well, Guy, thank you very much. That was an absolutely fascinating presentation. That's going to make a notable difference to many of our members. So I'm sure you're going to have the phone ringing off the hook, and your emails are going to be bouncing around. And thank you very much for all that.
Thank you.
So anyway, we'll now come on to the the next presentation. And I'm going to be calling on Brendan Shepherd at the Smart Factory. But before I bring him actually on and get him talking, I just wanted to say a little bit about him and about there's something here that we are called the Silverstone Technology Cluster, and it's well known that we're a cluster of highly advanced engineering companies, pushing 140 members now, and it's believed we're a cluster between Oxford and Cambridge. Now, Brendan's joined. He's from Limerick in Ireland. He's not only joined the cluster, he's very kindly agreed to sit on the Special Interest Group Committee, committing his time free of charge. And there's a big message here that's going out to the wider audience of advanced manufacturing companies. We're so strong together when we all talk and we all work together. So let's hear what Brendan has to say. I'm just looking at my notes here. CEO of the Smart Factory. Now, I know Brendan's highly experienced a consultant, especially with multinationals. He's worked with household names, and I know he really champions efficiency through innovation, and so I'm sure he's going to talk to us an awful lot more about that. So Brendan, over to you. Let's hear what you have to say. Thank you.
Thanks very much, Neil. Thanks, Guy, for your very interesting presentation earlier. Hopefully you guys are able to hear me okay. I'm just going to share my screen here now. Okay, so good morning, everybody. My name is Brendan Shepherd, CEO of Smart Factory. And today I want to talk about adding value to digital transformation. And there's a lot of hype around Industry 4.0, and truthfully, there's a lot of nonsense. So hopefully we can cut through some of that hype and explain some practical tips that people can use. I like this slide because it represents for me an awful lot of what's happening in manufacturing at the moment. Many companies and many world-class companies are struggling on their digital transformation journey. Some companies are leading the charge, are doing really well, they're very focused on the value and what they can get out of it. But there's an awful lot of companies that are struggling, and they're struggling because they're confused, they're unclear of where to begin. And I suppose the question is, what is digital transformation all about, and why is it causing all of this difficulty? And part of the difficulty from my perspective is the language that's being used around Industry 4.0, smart manufacturing, cyber physical systems, Industry 4. So there's all these terms, and really it's not about the manufacturing itself. It's about these labels that people, big data, digital twins, all of these things. And I think that language is not helping people. And I think part of the issue is, people are being presented this, you just press, install this sensor or press this red button and everything is going to be great. And it's not like that. And again, I think the whole kind of Gartner talking about the hype cycle and, some really interesting research, but unfortunately, every time we get to this trough of disillusionment, and it's different technologies, but overall, it's about, there's this wonderful expectation of what this technology is going to do. And then people kind of go, oh, this is tougher. Didn't expect this to be so difficult. Okay. Now what's that doing? It's leading to confusion. So what we try to do with our companies, our clients, is to try and break down in simple terms. How do you start? What is digital transformation going to do for you? Okay. So what is digital transformation? So fundamentally, it's about getting people away from paper and spreadsheets. So an awful lot of companies, world-class companies, are running their businesses on Microsoft Excel. Super technology, but it's not the way to run your business. Digital transformation is about interconnecting machines, factories, and people, supply chains. It's about providing actionable data to optimize operational performance. And that's a really important point, is that if you've got real-time information available to people where and when they need it, then you can really make a difference. And we see this happening continuously. Companies, they have the morning meeting looking at what happened yesterday, and it's like reading the newspaper from yesterday. It's historical data. You can't influence it. You can't make it better because it's already happened. If you can react to that data, then you have the opportunity to use data analytics to continuously improve. And this is a fundamental part around digital transformation. Digital transformation should support operational excellence and lean. And to me, very often those two efforts are disconnected. There's a whole part of the organization are very focused on lean and operational excellence. And then there's this disconnect between, what's the technology going to do for us? And the other thing that we're seeing is becoming really significant at the moment is the whole area of sustainability. And there's a huge focus now around energy efficiency and carbon emission reduction, all of that. So having data and being able to see, well, what is how much energy does this product take, and why is that product take more energy than this product? I think that also provides a huge amount of opportunities for companies to become to start to achieve their sustainability targets. The question is why? Why is it important? Fundamentally, the reason we're all in business is about being competitive and being profitable. And the opportunity that digital transformation presents gives us a chance to become more competitive by improving our efficiency, increasing our quality, being more agile, being more flexible, being able to develop products quicker. We know from experience that the lack of real-time data and the lack of people making decisions to real-time data is costing companies anything between 10 and 30%. And it's, most of our companies are world-class manufacturing companies. And even though they have fantastic systems in place, they have a huge gap in terms of the information that they're able to react to. This is a slide that we've adapted from the Aachen University in Germany, and to me, it really kind of summarizes, I suppose, the whole digital transformation journey. And what we see is an awful lot of the discussions in Industry 4.0 around this end of the transformation, autonomous systems, predictive maintenance, all of this fantastic stuff. It's really interesting, but most of our companies are here. And that's a long journey before you go from having operational excellence in place and lean systems to being able to have autonomous or predictable systems. And there's a couple of things that, in our opinion, and Guy touched on this earlier, we mentioned about the culture. The first thing that we believe that's important when you start talking about digital transformation is not the technology. It's about the vision for what problems you're trying to solve and what value you're going to create. And if there isn't that clear focus on what benefit are we going to get? Why are we doing this? Are we doing it just for the sake of technology? Or have we a clear business value and a clear vision of what that business value is going to be? And for me, this is absolutely fundamental. If you don't have that vision and you don't have that driven from the leadership from the top, then digital transformation is not going to fix your problems. And the other thing that's really important about digital transformation is it has a huge impact on people. And is the culture of your organization ready for this impact? Real-time information. People feel, now, are we being watched? Is this going to affect my job? Are robots going to take over? So there's a whole area of work around dealing with preparing people and preparing the organization for change. So fundamentally, from our point of view, it's about focusing on the strategy before you get too caught up on the technology. I believe the technology is straightforward. I believe a lot of it has been overly complicated, and I think there's step-by-step guides that we can talk a little bit about to talk about how to begin that journey. I'm going to give you just a couple of examples of these are two. We do a lot of work in discrete manufacturing, and these are two examples of medical device companies. They're global companies. They already had a fantastic culture of operational excellence in place. The first company making catheters, manual assembly process. They won the Shingo Prize for operational excellence. And we installed on these manual workstations where people are bonding and cutting and joining pieces of tubing together, inflating balloons. We installed our wireless sensors around the line. And they managed, on the first line, they managed to increase the output by 13%. A second example is another medical device company that make a braid machine. And they had 35 of these braiding machines in one area. The person operating the braiding machines had been there for 12 years. He knew everything about the process. So he was highly experienced. But the amount of downtime and the amount of time lost through changeovers, and again, it was all based on not having real information. Within a couple of months, they had increased the output by more than 10%. They've now increased the output by over 18%. And the interesting thing is that they didn't have to invest in new machines. They didn't. All they're doing is changing how they're operating their machines. Okay, so this is around our view to having a standard execution strategy. We believe, again, Guy touched on this. Rather than trying to boil the ocean, pick a sprint. You know, be clearly focused on what are you going to achieve. What can you do in 8 to 10 weeks? Okay, define the business value. Be really clear about the user requirements. What are we going to get out of it? Test it, install it, validate it, and get it up and running. Okay, so I'm going to talk about just a couple of examples from industry that we've been working with over the last couple of years. A lot of issues that we see are dealing with companies that have strong culture of operational excellence and a strong culture of lean and, you know, whiteboards recording information, but all done on a manual basis. So typically we're having to go in and work with the operational excellence team and to try to integrate digital transformation and that sort of lean systems that are already in place. Very often the machines, we've got, you know, world-class companies, and often their machines are 10 or 15 years old. So how do you install a system to connect to legacy systems? How do you connect onto a machine that has a PLC that's obsolete, that's no longer, the machine might be running perfectly well, but there's no way of actually connecting into that controller. Again, typical prerequisite for us would be how can we install something that can grow and meet future demand? You know, so you install it on one line, again, trying to design it in a way that it's a short sprint. So get it installed in one area, but with the objective to install it across a site and then across multiple sites, so you can start to compare the performances in different sites. We were just speaking briefly before the session started this morning about cybersecurity. Cybersecurity is, you know, becoming such a critical aspect of connectivity and the whole area of cyber attacks, etc. So it's too late to think about cybersecurity and data integrity at the end of the project. That has to be built in from the start. So it's really important that those elements are taken account in the design right from the start. As we start to get the data and start to bring that information together in databases and historians and workflows, that data should be presented in a way that it's clean data, that it's already processed, that people can get value out of it. And ideally, that data should be designed so that it can integrate into advanced data analytics systems like AI or machine learning. I'll show you an example of a project that we've done recently on that. So it's really important that the way you get the data and the way you present that data is how it's structured is done in a way that allows future analytics and more advanced analytics of that data to be performed. Okay, so here's an example on a simple medical device line. Okay, so it could be any manual or semi-manual process. In this case here, we had an operator pressing a foot pedal. We put a wireless sensor on that foot pedal, and we connected that into a historian and into a day-by-hour. This is a day-by-hour graphical or visual representation of how the line is performing. Yes?
Brendan, sorry to interrupt. We seem to have lost your slide. Are we meant to be looking at slides? Because
You are? Yeah, sorry. Am I not
would you
sharing?
mind sharing your screen again?
Huh.
I got the impression you were talking about something that we were meant to be
Yeah.
seeing, and we weren't. So if you could try that again.
I'm not sure how far back to PIM was that?
Oh, not very long, I don't think. But especially when you were talking about, and here's this example.
Okay.
So we see your desktop at the moment.
Okay. I'm going to go back to my PowerPoint, I hope.
There we go.
I'm not sure what happened, Pim there. Sorry about that.
Not to worry, not to worry. We're back in. So sorry to interrupt. Thanks.
Okay. Thank you for the heads up on that. Apologies, folks, for losing the connectivity there. I'm not sure how that came about. So this is kind of a graphical representation of what we do. So it's around connecting to systems, be it machines, processes, or people, bringing that data together, often integrating data from other sources, so databases, ERP systems, etc., warehouse management systems, and then workflows. So, the tasks that people do, how do you know that they've done what they're meant to do at the right time? So that's our kind of approach in terms of the infrastructure. And then being able to bring it together in a way that can be analyzed. Sometimes it goes to the cloud. As Guy mentioned, a lot of companies are still very reluctant about cloud and have concerns, and I think justifiable concerns around where that data is. So maybe it's on an internal cloud or an internal virtual machine, etc. And then ultimately all of the data comes back into for us, it's dashboards, what we call the visual factory, so that we've got TV screens and monitors, laptops, tablets around the factory that people have real access to real-time information. Okay, so I'll just, this was the slide that I was starting to share. So here, just an example from a medical device line. So on this line, people are bonding pieces of tubing together, and they're cutting the tubing, and they're welding, and they're inflating a catheter or whatever. On the outside, you say, well, there's no automation on this line. How can we capture it? There's no PLCs. It's all little controllers and heaters, etc. How can we gather data from this? And what we ended up doing was putting sensors on foot pedals, on pneumatic switches, on little photo optics on pouch sealers. So as the part moves around and breaks the beam, we send a signal wirelessly and we count one. And we present that data then in what we call a day-by-hour dashboard that shows what's the target every hour, what's the actual every hour, am I red, am I green? Again, very visual controls, supporting all of the kind of culture of operational excellence and lean and continuous improvement. Again, how do you bring that together in a way that's secure and dealing with wireless sensors, reliable, all of that. So there's a whole element of that to be taken into account in terms of the infrastructure of the system. Ultimately, then we take all of this information and we present it in a Power BI type dashboard so that the information can be sliced and diced. So maybe the finance department, they care about one aspect of the business. Maybe the engineering maintenance guys care about a different aspect. So very important that the data is in a format that can be aggregated and assessed through different perspectives. This is another example. This is an industrial, completely opposite end of the spectrum. So on one side, you've got this medical device process, which is manually assembling components. And then on this end, you've got this industrial spray dryer that's huge. It's one of the largest spray dryers in the world. Their energy bill is 15 million a year, 15 million euros a year in this site. And they had a huge amount of data. So they had SCADA systems and PLCs and controllers and quality systems and all of this silos of data all across the site. And what we ended up doing was putting in our data acquisition system and putting in a series of wireless sensors where data was missing. So we connected to the process where that data was available, but then we supplemented it with IoT sensors in areas where that data wasn't available. So electricity meters, they had individual electricity meters, but none of them were connected. They had gas meters. They had all of these meters, a huge amount of meters across the site. but they couldn't bring it all together. So we're now bringing all of that data together in these dashboards that are showing real time. What's my energy consumption? What's my OEE? How many tons of product am I making an hour? What's my top losses? What's my process variables? How come when I run this product, it varies versus when I run a different product? Okay, so this is manufacturing baby nutrition. Like I said, their energy consumption is huge. We're logging, so they have thousands of process variables. We're logging about 1,200 of those process variables into our data collection system. And in 6 months, we had about 6 million data points. Okay, so we're gathering about 1 million data points a month. And the phase we're at now is we're working with a center here in Ireland called the CDAR, which is Ireland Centre for Data Analytics. And we're looking at am I still presenting okay? I hope so. Yeah. We're looking at the variability of the process and the products, and using artificial intelligence to identify how come different products behave differently in the same process.
Brendan, sorry, your slides have
a bleeping message. I'm not sure what that is for, but
Brendan, can you hear me?
I'm going to keep going. Again, just to finally, just to close out the presentation, looking at condition monitoring, using wireless sensors to measure energy consumption, gas, etc., or vibration. Again, being able to predict when air handling units or vacuum pumps, etc., will begin to need maintenance, or when being able to predict using algorithms when the ideal behavior of the drives and motors, etc., has gone out of its optimum operating range. This is another example of, again, bringing digital transformation technology into a manual process. So this is a medical device application, and it's called a Pictolite system. Some of you may be familiar with a Pictolite system, but it's ensuring some very simple processes, but it's ensuring that manual processes, picking parts, picking paperwork, for example, and putting it with the right hardware, putting it with the right components, making sure that those parts are always correctly linked through RFID readers or barcode readers, etc. Okay, so that's I think that's as much as I was hoping to cover today. I'll end the presentation and happy to take any questions now. Thanks for your time.
Well, thank you very much, Brendan. That was absolutely fascinating, and I particularly like the idea that you can take the fear away from people by introducing this in the right way. I'm going to ask Les Gill to come on stage temporarily. He's been putting in a couple of questions. So if I go on to show on stage, we should have it here. So he's got, with the factory of the future, could the role of supply management be taken over automatically, whereby the customer order can be seen throughout the supply chain and volumes turned up or down accordingly? And a fascinating question, I'm sure you'll agree.
I think supply chain and the whole area of supply chain inefficiencies is one of the huge opportunities with digital transformation. And a lot of our companies have run SAP, for example, but their suppliers don't run SAP, and they get an order in. We need 100 parts by Tuesday, and now it's like scrambling to get people to work overtime, support maintenance over the weekend for people to. So, but the actual company, the customer, they knew that they had a big order coming in. So they knew on Tuesday that they were going to need these parts. But the lack of communication through the supply chain is what's putting this unnecessary pressure, particularly on the smaller suppliers. So there's a lot of work. We're working with some of the universities here in Ireland, actually, at the moment, around this supply chain inefficiencies, if you like, because there's an awful lot of inefficiencies. And absolutely, the problem is that not everybody is connected to the same system. Right. So various people along the supply chain have different bits of information. But by and large, that information is not interconnected at all. And I think there's a huge opportunity in terms of efficiencies, and that we've seen that particularly in during COVID, where suddenly supply chains become under huge pressure, and really they started to creak at the seams. And I think there's going to be a benefit from that, because people have really looked back and said, does it make sense to be buying cheap, low-cost stuff in China when it takes 3 months to get here? And why aren't we manufacturing it on our doorstep?
Mm.
And I think so. So there's, in my view, the one of the positive outcomes from the COVID pandemic will be examining supply chain and examining the inefficiencies and the location of manufacturing and saying, why not?
Yeah, I fully agree. One of the challenges we're facing in packaging at the moment is just knowing where everything is, individual parts. You're packaging thousands of parts and sending them even just all over the country, never mind all over the world. You actually want to know where they are in real time these days.
That's right.
And you don't. You know, they leave your factory, they arrive at another factory a day or two later.
Yep.
Where have they gone in the meantime?
Yep.
Yeah. Big challenge, big challenge. I mean, one of the questions I'd like to ask is that, you know, let's say I've got my own company. I've got 10 machines in the hall, in the factory. They all do slightly different things. I've grown over the last 10 years. I started off with one machine. I added another one a year later to do a slightly different job. So I've grown like most companies grow. How do I suddenly make all those 10 different machines all want to talk to each other?
Yeah, and I think that's one of the key areas is around the standard. You know, so what's standard? We believe OPC UA is the standard. That's what every system we put in is built around OPC UA. Different companies have different perspectives on this. Guy mentioned about, again, all the different kind of legacy standards that have been out there and some of the new ones that are being developed. Our feeling is that all of the work we've done over the last 4 years has been around OPC UA. And it's growing continuously. Every year, there's more people joining that alliance, if you like. Unfortunately, some of the legacy machines don't have that connectivity, don't have that capability. But I think you have to start and say, okay, what would be the ideal standard? Right? Is it secure? Does it meet all of the requirements in terms of data integrity and security? Right? And once you agree that standard, then you have to look at the list of machines. So we did an assessment of an injection molding company. They make toothbrushes here in Ireland, and they had 380 machines on site, and a third of those machines had no connectivity. Okay, so on all of the machines that had connectivity, we just used the connectivity, the Siemens and the Allen Bradleys and the Mitsubishis and all the rest, connected with OPC UA. On the 30% or so of the machines that didn't have connectivity, we put wireless sensors on them. And we did a cost benefits analysis, and we said, okay, we could upgrade, we could shut the machine down for 2 or 3 weeks. We could upgrade the PLC. We could spend anywhere between 5,000 and 15,000 euro on that cost. Or we could put a wireless sensor that costs 400 euros on that machine and probably get 80% of the benefit. And that's what they've done. So to me, it's about, but even it doesn't, for us, it doesn't matter whether it's coming from a wireless sensor or an OPC connected PLC. Our infrastructure, our architecture, our data storage, all of that is the same. It's the same standard across the site, whether it's energy, whether it's parts, whether it's meters, whether it's kilos, we're using the same infrastructure.
Yeah. Well, Brenda, that's absolutely fascinating. A really good contribution to today's meeting. Thank you very much for that. And if you'd like to leave the stage now, because I'm going to bring in the next speaker. And I hope the audience is starting to realize that this isn't anything to be scared of. You know, we're all fairly small companies, with a few exceptions, but and it's actually hard to get out of the habits that we have sometimes, and especially when we see this sort of thing on the horizon. You know, so don't be scared of it. And I think this is something that Dolores is going to talk about. So welcome to the stage, Dolores. I know you're sitting in my hometown. We're in slightly different parts of Northampton. So the heart of British advanced manufacturing and British Formula One and the motorsport industry and things. And there's a few reasons why I've been really looking forward to your presentation. I mean, not only did you win the Women in Innovation Award, congratulations for that. That's a fantastic achievement. But you also, I know you like to talk about how manufacturing today is data rich but information poor, and you want to actually make it relevant to people, and relevant to the SMEs that make up the vast bulk of the STC. So without further ado, over to you. Thank you very much for coming today.
Thank you very much, Niall. I really appreciate that. And actually, just a continuation, and the last two presentations have been absolutely brilliant and right in our space, being the digital manufacturing event that we're doing. But absolutely, you're right. My passion is for bringing the kind of technologies that we've just been hearing about, the advanced metrology and the sensor checking and all the device connectivity, but bringing that to the SME marketplace. My purpose here today, I'm going to try and share my screen. I appreciate there were some challenges. I hope I don't drop off from doing that. If I do, please somebody wave at me very loudly. Good. I got lots of thumbs up. I love the thumbs up. That's brilliant. Interaction as we go. So so my purpose for being here today is to share with you some work that we've been doing on a prototype, working with the Digital Accelerator that's been put together with Made Smarter and the Digital Catapult and Safran, with ourselves providing the technology, but also how our own work has been part of a collaboration as well. So I hope to bring a lot of the themes we've already heard this morning: collaboration, bringing technology so it can actually be applied and effective, taking that digital journey. So and bring those things through. But I'm aware we've had lots of new members, and I'm going to, if I can make my slides work, I'm going to just do a brief overview of what we are, Total Control Pro, and what we do before we get into the nitty gritty of the Safran prototype. But I'd also really encourage you when we do that to ask any questions, because I'm happy to answer questions on anything to do with both working with the Digital Catapult and the funding and those opportunities, providing our technology and the sort of solution that we actually have devised, but also that interaction between a large OEM and a small technology provider, and some of the things that's brought up as well, because I'm really passionate that we bring to the STC the opportunity as a group to learn from each other, so that we really can be best in, provide that best practice. So who are Total Control Pro? Well, we are aiming to unlock manufacturing operations in production facilities using cloud-based. I know we've had some negative things about cloud-based today, but cloud-based interconnected applications. Why cloud-based? Mainly because it's what makes it available to an SME market who can't run an enterprise-based software, servers, etc., and don't have an IT department to manage that. So we want to take that effort, that challenge away from them. But also recently I heard when we talk about the sustainability, an AWS enterprise server runs 88% more carbon efficient than an in-house enterprise server. So actually, if you're moving towards sustainability, a very, very good way of ticking that box and moving in that direction is moving your software management to the cloud. We talk here about AI ready, and I wanted to challenge that. We have devised a platform of interconnected modules that's on the latest technology. We say it's AI ready because, as we heard this by Guy, AI, machine learning, it's all a bit sort of thrown around and bandied around as hype. And really, we're taking advanced data analytics, starting to apply a technology that can learn, but then deploy that learning so that you can create a feedback loop and actually start to really fully implement machine learning and then AI on top of that. So we're in that journey. We have the technology architecture to do it. It doesn't mean it's always gonna, there's an AI algorithm to resolve everything. There really isn't. One of the things that we absolutely commit to is people. We heard that before. People are there. What is it? Peter Drucker said that culture will eat strategy for breakfast. Personally, I'd rather eat it for tea. But it is the fact that we need the people that are there and working. And often when we talk about digital manufacturing, we forget people. A lot of the technology is involved. Device connectivity, real-time data tracking, process, off machines, what are the parts doing? But what are the people doing on the shop floor? Are they programming the CNC machines and then going off and doing something else? Are they the right skills being utilized in the right areas? We are suffering from skill shortage. So are we utilizing the resource, which in the UK manufacturing is still the major resource for any manufacturer, and that's its people. So we're always trying to align our technology with a pragmatic approach to how it can be used and help people do their job better. So what does this aim to create? We've heard it today, absolutely. Managing the process management, optimizing available manpower, streamlining supplier inventory, and coordinating resources. All of these things enable you to get the information you need to plan your manufacturing most effectively. And this has been something that we've been working on, and those members have heard us speak before. We've been working on, 4 years and bringing the right parts together. But we talked about that supply chain thing, and for me, one of the most important elements is we bring the technology that is affordable for our smaller suppliers and smaller manufacturers to be able to have the same level of visibility of their production and what they're doing as the OEM. And when you bring that together and bring that into the marketplace, then everybody can start to have visibility all the way through the supply chain. So that's a sort of just an overview of what we do. We provide our manufacturing operations platform to a broad spectrum of different manufacturing environments. We pride ourselves in it being a product that's configurable and can serve multiple manufacturing best practice, but built upon lean principles, because as we've heard already today, that's absolutely the best practice in manufacturing. And we've served a number of customers, from very large customers to smaller, to good well-known names, to not very well names, but serving very, very important processes in the supply chain, and also not just in the UK, but in the broader market as well. But today, what I really wanted to talk to you about was the project we've just been working on. So, we have a product, we supply our customers, and we're always looking at innovation. Where can we go next? One of the reasons that I won the Innovation Award is because we're going, what can we do next? What can we find next? How can we bring this technology in a way that's configurable and pragmatic and serves the smaller manufacturer? So when the Digital Accelerator project came up, we had an opportunity to pitch on 14 different challenges. So there were 14 different challenges from different large organizations, so that we thought we could bring our technology to serve them. There was some cash involved, which is always nice. The Made Smarter Fund was providing some funding for the prototype. The industry challenge with bringing their challenge, plus their resources, plus their data. So it's the opportunity for us to really take some of the things we've been testing into a practical environment. And also the Digital Accelerator was working to provide us with other elements. So additional AI and machine learning expertise, user experience expertise. They've been operating in the digital manufacturing space for a broad length of time, and some great project management and stuff. So it's been a real collaborative approach. And we actually did the sort of final pitch, public pitch about this yesterday afternoon, which is why I was really excited to bring this to you today, because it's essentially its first time airing where it's not within the environment of the Digital Catapult. So what was the challenge? The challenge that we were facing was that Safran were, in reality, had a massive planning problem. They utilize SAP. They have a MES system that gives them some sort of visibility of what's going on on the shop floor, but the planners were sat in an environment where they had lots of different information, lots of different data, and they were ongoingly managing, lack of resources, things not running to time, trying to interpret the information from all these multiple sources, and it became a very, very manual planning process. And if this is a challenge being appreciated inside of a large organization with large resources, we know it has to be an issue for SMEs. So what we looked at, what would it be like really, that if you could continue to monitor, analyze, schedule, and instruct an optimum workflow, and indeed learn all and everything in real time. So, as I said, the planners are getting information from sales, they're getting information from distribution, from inventory, from production, from suppliers, and often that's coming from different software solutions. So, in an SME environment, this would be a different Excel sheet or a different Trello board or something. But in Safran's environment, there was a lot of data on SAP. Anyone who's a big user of SAP know it's not particularly visually intuitive, and it's quite hard to find the data you need sometimes. So they're learning from that, from a large organization operation. They had specific cell-based activities, and it often didn't have visibility from one silo of production through to another either. So bringing all of that in together. So our offering was to start to create an adaptive planning system to make sure that everyone had the right resources in the right place at the right time, doing the right task for the right job. Nice ask, yes, I'd like to say we waved a magic wand and we solved that problem immediately. But it was absolutely great to work with Safran to sort of breathe life into this project and start to see what we could create and really test our hypothesis in creating this. So I talked about collaboration. It was important that we brought the right team together. We obviously had the Safran team working here with us, some of their planners, their special processes, bringing their data to us. We also enabled us to work with the University of Northampton to actually bring some of their AI PhD students and Professor and Dr. Mumu in to work with us as well, and that actually came through the collaboration through the cluster, and then our own team bringing software, data architecture, product design, and generation from myself, and it's all bringing all those elements together was absolutely key. So what was our challenge? We are in a CNC cell. So we heard this morning already that CNC cells are like a goldfish. They know what they're doing in the minute they're actually doing it, but any time before and any time after, they don't know what they're doing. That was exactly what we had. I mean, I loved it. I wish we had a goldfish on this screen. Essentially, the prismatic cell in Safran was a goldfish. It just dealt with what it had to deal with when it was there. And the planner's challenge was getting the right, the understanding of what it needed to have, and then what was happening in and out, because the prismatic cell, although it operates on its own, special processes happen in and out and around it. So our role was to understand those special processes that were happening, the tooling requirements, the labor side, and actually start to bring all of these elements together so that they could have an effective dynamic work to list, and then we could start to learn in their response to the work to list what was operating. So what that means is, here's the things that I need to do on the in this cell today, but I'm actually going to work on this one first or this one first, and then getting some feedback as to that contextual data about why they were choosing one over the other, and actually learning from real-time data as well as the historic data that we had in the past. So we started by first of all setting up some context for the game. So we needed to know the departments, we needed to know the resources, so we need to know who was on site, when they were on site, we need to know when the machines run. There's a slight change operation in the sense of if there's not a human person with the machine, then the machine is not working. So actually in some environments, machines can work 24/7 and they just need an operator at certain periods. That's a planning challenge. In other areas, you've got the machine. In this environment, the machine can only work when there's an operator present. So we had to align the resources, ensure that we could manage, break times. Humans do need to take breaks alongside the machine times, and any exceptions that went on, such as certain tooling sets that could only be used on one of the machines in the cell or not, availability of different tool combinations. All of those elements were factors that we started to analyze in the machine learning and the historic data that we received, and we were able to then start to set a structure using our platform to enable us to constrain the capacity. So this is your actual available capacity to work on. What we found was the plans that were being provided to the planners at the start of this process were on an infinite capacity. So they're working, and that's an SAP standard. They're working on the basis that machines are always available, that the resources are always available, and that the inventory is always there. Now, I don't know about you guys at manufacturers, but the machines aren't always available, the people aren't always there, and the inventory is never on time. So, that immediately you're setting yourself up for failure. And what we wanted to do was start to create a capacity that was based on reality that would set us up for some success from the beginning. So within the prototype, we started to take that learning from the historic data of how plans had been divided, how effective those plans had been. We didn't have the contextual data as to why the plans had or hadn't been followed, but we did have a success rate in terms of the plan itself. We were able to take that and start to generate some optimized opportunities and start to create some optimized planning elements, but also give the visibility of that information. As we just heard, the importance of not just the data, the analytics, but also the visibility, to provide a work screen that enabled the planners to automatically move things around, see the impact of delays, see the impact of queue times, and the impact of moving one job to another. What this is starting to do is actually, by utilizing the dashboards that we have, we can see the planning process, which before was not available. The planner would go, I'm going to move this here, or put this here, or I have to stop this and move this because of availability of inventory. But the decision making wasn't understood. It was just, the capturing of those movements. So we're now able to do that. So again, we're enriching the data so that we can start to provide more and more powerful learning. So inside of our prototype screens, you have machine availability, you have practical things like the forklifts that have to move parts or pallets from one area to another. Often these contextual information that is missing inside of capacity plan. Manpower, as I've talked about, dates and filtering, which areas link with which areas. So as you move things around this plan, the impact of other things, and you can always just reset and set it to the machine learning optimization. So what we wanted to enable was a sort of a scale of autonomy. The planners have had 100% autonomy in how things are planned, and so we can take them on the journey for this advanced and dynamic planning. We need to show them how this is our optimized plan, and you can still move things around and see the impact, and then learn from that intervention to improve and to bring that through. So it means that from our planning perspective, they can deal with the outliers, the exceptions, instead of having to do a lot of the day-to-day business as usual work. So the main element is we import and bring that work demand in. So the work demand we're still bringing in from their SAP system. You plan and execute it against the required demand, and then they release the plan into the machines and people. And this is often an area that's missed, is you can have a perfect plan, but a perfect plan not acted on is not a plan at all. So, we needed to create screens that enabled the plan to be acted on and fed back. And for our prototype, that was in a very kind of discrete environment. We're not going to, going down, we can connect into the MES system, and we can start to drive it across the rest of the plant. But for here, we wanted to make sure that inside the cell themselves, they had that feedback loop. So we started to create the visualization, so end of line screens where exactly what was being worked on, what was available, what's next. We call it our train line system. So for the special processes that were happening outside of the cell, they could see what was happening inside the prismatic cell and say, okay, this item is coming to us next, or this item is now in operation and will be with us at this point. And then in the prismatic cell, always now known as the goldfish bowl, I can't think of any other way of describing it, that goldfish can now say, oh, I'm supposed to have this in a little while. Am I going to be ready for it? So we're actually giving the goldfish some learning. So thank you, Guy, for that. I really appreciate it. Talk a bit more about what this has enabled us to do. So, the output of the prototype. This is some quotes from Par Ellison, who we're working with, that they can now see how the planners can spend the time on value-added activity. They can improve. They've already seen how they can improve on-time delivery. They're going to see the factory efficiencies and optimize their key production KPIs, one of which is the inventory costs. It's a significant impact, the inventory costs through the production cycle, and we've already identified saving 10,000 hours, but one that replicates for this particular specific cell of over £100,000 on an annual basis in terms of the right inventory or the right resource being available at the right time. So we started to demonstrate the improvements and the possibilities inside the cell. But what I love about having done this is a large number of SME manufacturers have a CNC cell. Whether you are Safran working on a global scale, providing landing gears for, highly sensitive aeroplanes, etc., or you are a machine shop with a CNC machine that's running and everything else around is manual, we can actually take this because of our approach of having things that are configurable, that are available to everybody, that we can do it on a cloud system that makes it affordable. We can see how we can start to now provide adaptive planning in a methodology that will be useful to small manufacturers. So it's about taking it, making it, improving upon it now. So what's next for us? We are now pitching for the MVP. So we're going through to the MVP stage with Safran to build this out across the other areas on the plant. We are improving and getting this real-time data loop coming back through to start to improve that learning algorithm and start to see what are the commonalities. So my Women in Innovation project was looking at benchmarking and commonalities across small manufacturers. So we have some of that research we can now bring into the adaptive planning and layer that on as well. So we're starting to get more and more interesting analytics that allow us to start to develop the exciting kind of buzz hype stuff around AI. But it all does in the end come down to having a very, very strong, pragmatic data platform that gives you that real-time data, that gives you what's going on and allows you to implement changes and improvements in a very effective and efficient way. And I think, to do that, it's not just, our solution. We absolutely know that there's multiple collaborations within other technologies, interacting with the sensor details. All of those information needs to come through as well. But I hope that you found that useful. We've certainly been really excited to work with the Made Smarter project, and I'm absolutely delighted to take any questions.
Well, Dolores, thank you very much for that. I think that was so relevant to so many of our members. We see, and we're about to see a presentation after the break, big companies taking all these things on board. But it's quite a challenge. It's almost scary for small companies sometimes. And you've just explained exactly how we can do it. I have got one question, actually. You alluded to Made Smarter and UK government initiatives. Can you actually help win UK RI funded collaborative funding, and perhaps help with bid writing to install your Safran technology into SMEs?
Absolutely, it's we we have had the Made Smarter adoption project, which has been in the Northwest, and we have worked with a number of manufacturers up there to actually create the project briefs and have them bring on the funding, which has been really successful. But there's more and more funds coming available now on a wider scale across the UK. So yeah, and it's we've also worked with people doing the R&D tax credits and those elements, because it does say that if you're collecting data from your current operations with the intention to do something useful with it and make improvements, then that can be part of your R&D claims and the tax credits elements. So there is lots of funding around to help support this. Having said that, we do pride ourselves on not being terribly expensive, so you don't need a high capex element for us, but it is often that we then will utilize any of that capex bring in for the sensor details, for that information to help bring those together.
Yeah, I fully appreciate that, and I know that you do have the reputation around here, certainly, of being very, very cost effective. Niall,
you can't tell me I'm cheap. That's a terrible thing to say.
I would not say that at all. I think, but what Safran would call a rapport qualité prix is the relationship between the quality and the price is very, very good.
Absolutely. Thank you very much.
Well, thank you for your presentation. Now, if I can just address the general audience, we're going to have a break, a networking break. So please grab yourself a cup of virtual coffee, perhaps a virtual pastry. They're less fattening, of course. And go and join the tables. Please take the opportunity to go and wander around, go and talk to as many people as you can. And we will be back live at 11:30, where we're going to have a presentation from Dimitrios Spiliopoulos and Stephanie de Albuquerque from Amazon Web Services about market trends and future developments. So thank you very much for your time so far, and we'll see you back here at 11:30. Right. Well, welcome back to the second session. I hope you've all enjoyed the networking, and you've had some good conversations at the tables or the virtual tables, and I hope you're all refreshed. Our next presentation is from Amazon Web Services. So we will have Dimitrios Spiliopoulos doing a presentation, supported by Ollie Given and Stephanie de Albuquerque. So Dimitrios is the Internet of Things strategist at AWS. Ollie and Stephanie are territory managers, and they actually cover the area covered by the Silverstone Technology Cluster. That is the the Advanced Engineering Arc from Oxford to Cambridge. So welcome to the stage, all three of you. Thank you very much for joining us today. Obviously, Amazon is a disruptor, famously so, sometimes controversially so. But my message to the audience is, look what Amazon have achieved with the tools that they've invented and they've taken on board. Because if you don't look at them, your competitors will. And suddenly you're going to find yourself uncompetitive. And this is, I think, the insight that we're going to get from Amazon here. Amazon have done it on a world stage. They are world class. And so it's a great pleasure to have them here today, providing insights into, well, how you guys can actually achieve this sort of thing on a smaller scale. Over to you, Dimitrios.
Thank you, Neil. And thank you, everyone. Thanks for the invitation. My colleagues Stefan and Oliver will start just by introducing AWS and why we are here. And after I will speak more about the connected factories and some customer examples and trends. Thank you.
Perfect. Thanks, Dimitrios. So yeah, today we're going to cover off as an agenda. We're going to give you a bit of an introduction into who AWS are, and then we're going to pass over to Dimitrios. He's going to cover off some manufacturing marketing insights, some customer stories, because obviously it's important to show you where we've helped customers before. And then we're going to show you how you can start to leverage AWS for your business. And I think we're going to leave some time at the end for a couple of questions. So perfect. Next slide, please, Dimitrios. Thank you. So yeah, sitting in a couple of the breakout rooms then, I think there's a bit of a mixture in terms of who knows AWS, who knows cloud computing and who doesn't. So I'm just going to start from the beginning really for those that haven't heard of cloud computing or AWS before. So cloud computing is the online, on-demand delivery of IT resources over the internet on a pay-as-you-go pricing basis. So instead of buying, owning and maintaining physical data center kit, what you can do is access those technologies over the internet, technologies such as server compute, storage, databases, on an as-needed basis through companies such as Amazon Web Services. And a couple of the main benefits really, low cost. So we often see customers saving up to 60% on their CapEx on-prem. Elasticity, you can really scale up and down within seconds. So you can provision servers within less than 5 minutes. Flexibility, similar to elasticity, you can change your services from seconds. Security, at AWS, we put security as job zero. We've done it for years. You don't have to worry about the physical security of your data centers. We handle that for you. And then global reach. We have a vast range of regions, availability zones all over the world, meaning you can deploy your services close to your customers. So yeah, just a few of the benefits there really. And I'm just going to pass over to Steph, I think, who's going to cover off the next few slides.
Yeah, awesome. Thanks, Ollie. So our leadership in compute and cloud really comes back from our customer obsession. We innovate on behalf of our customer needs. So today, about 90% of our product roadmap is based on customer feedback. It's our customers are really pushing the boundaries of what's possible today and driving us to think about new scenarios and capabilities. So even in the breakout rooms earlier today, I heard some interesting use cases, some challenges, and we're always keen to hear about those because we're really here to understand how we can support. Other services really support customers from an enterprise background, a startup, or a small medium business. In fact, as you see on the slide, we see that 85% of small businesses using AWS say that the use of cloud made it easier for them to flex their IT and meet their business needs and to help them save costs on the way. Can we move to the next slide, Demetrius? Yeah. So moving closer to the topic that we're going to cover today, AWS being born from Amazon allows for vast experience in the industrial operations space, from manufacturing to warehouses to supply chain. So if you think about it, an Amazon fulfillment center works very similarly to connected factories. And there are other multiple different use cases like connected devices and smart home. So I'll pass it on to Demetrius now to deep dive on this topic a bit further and drive the discussion from then onwards.
Thank you, Stephanie. And yeah, AWS was born out of Amazon, which is kind of in the industrial space. But also, for many years, we are serving customers around industrial sectors, from different subsectors of manufacturing, I would say, from pharmaceuticals to chemicals, automotive, aerospace, across industrial sectors. Here are some brands, and I will cover in a few minutes some examples from these companies. And don't worry, I will not speak for 15 minutes about the services, but you may wonder what is the play of AWS in manufacturing. So just to tell you, apart from the classic cloud services, we have many software services that are focusing on industrial IoT, on machine learning like SageMaker, or edge computing like Greengrass. And we can help you, or partners can help you put all of these services together in order to create your platforms for connected factories or for connected products. And let's talk now about what trends we see from our customers in manufacturing, and and after we'll see the examples. So first of all, I think this was also discussed from other people at the roundtables and probably from the previous presentations, that data is the enabler of manufacturing today. And we see more and more customers are coming to us and they say, hey, we have the data, but we are not able to see it in real time. We're not able to combine data from different machines or from different sites. So we see that more and more companies are looking to use the data they have or the data that they want to have. The other trend we see is that about the digital executed manufacturing, which means about having real-time data in order to do the OE, overall equipment effectiveness metrics, and achieve the goals of its manufacturer. And this is by using machine learning, robotics, computer vision, and industrial IoT. The third trend we see from our customers is about products as a service, and this is mainly for customers that they have already made at least the first connected product they have, and then they are moving to as a service. They're changing the business model and they're trying to offer new services to their customers. And the fourth trend is about connected products. You can imagine traditional manufacturers that they were selling boilers or pumps or any mechanical industrial equipment. They were selling for maybe for decades or 100 years. Now they are looking to connect their products and get more insights from their customers, how they use it, but also to avoid the problems. Sustainability, I would say, is the latest trend that we see, especially this year. More and more customers are coming to say, how can technology, cloud, IoT can help us achieve our sustainability goals? And also, this is driven by, I would say, in UK from regulation. And I don't know if you have seen in March, the government, the base department, announced the industrial decarbonization strategy to support manufacturing and industrial companies to achieve their decarbonization goals and reduce energy consumption, reduce waste, reduce water, so we can have a greener future. And these are areas where we are helping customers. Some use cases, I assume more or less you have seen them, like production process optimization. More and more companies are looking how to optimize their production by using real-time data, predictive analytics, edge computing. Predictive maintenance is, I would say, the most common use case today. This year that customers are coming to us by using the existing data they have from their machines, bringing it to the cloud, and then applying machine learning. Machine as a service, as we discussed. Digital twin, I think this is slowly becoming a trend. More and more customers are using our services to build a digital twin for their machines. And I have an example later. Computer vision for quality control. This means that they use cameras that they can run video analytics to understand if the quality of the product that the production is at the right status. And also recently AWS launched a service, Outlook for a vision or Outlook for equipment, that you can just put 30 photos in these in the algorithm, and there is already trained the algorithm for AI, and you can do the computer vision to understand the quality of the products. And you don't need to have artificial intelligence experts in the team or high, very expensive staff. Just the software engineers can do this, which is very cool, I would say, and more customers try to use it. Automated material management, another use case, which means the use of robotics for material handling in the factories, but also in the warehouses. Amazon has, of course, lots of experience there, but we see also many other customers are coming and to apply this kind of use case. Track and trace, other use case that we have seen, especially I would say in food and agriculture, but now it's coming, I think, also with in pharmaceuticals, in mining industry, or precious metals, to trace the origin of a material, but also to track it throughout the supply chain and be sure that it is from the right origin and at the promised and expected quality. And OE visualization, I think the key here is about visualization, giving access to many different stakeholders in the factories, give access to the right data and KPI and metrics, and from the real-time analytics and OE dashboards. And we are investing a lot to create these dashboards for our customers. And I'm keen to hear maybe at the Q&A, but your opinion. But the journey that we see so far from our customers is that they are starting first with their products, to connect their products and be able to understand better their users and understand the data they get. And they try to offer more added value services. This is the first step. Then they're looking around digitalizing their operations and their factories or their supply chain. And third step is to combine the data they have from their connected products, from their connected factories, and try to really innovate by changing their business model, changing their the services and the way they sell or they serve customers, and more importantly, to offer database services. Maybe not making money only from the product, but also selling anonymized data and new insights to other customers. Let's see now some customer examples that I think are interesting here. A couple of stories from connected products of manufacturers like iRobot. You may have it at your home or other brands. These are the autonomous vacuum cleaners for homes. I think every household is happy with this autonomous cleaning, and they use our AWS IoT services in order to scale to sell millions of robotic vacuum cleaners and be able to understand how the customers are using the products, to do software updates for security or improvement of their robots, and also they're able to they are thinking like now how they can do new services for the customers that they can monetize. The other customer is Vantage Power from UK, that they are building batteries for buses, which is the red buses, especially in London, and they are using IoT to monitor remotely the status of the battery, how full they are, if they have any problem, in order to do some preventive maintenance. Some other examples from manufacturers in the factory that I think they are relevant to almost every size of manufacturer. I would say the first is a digital twin. It's not the most common use case, but as I said, we have customers using it. And my favorite example is with Penter. They build water filtration systems for breweries or fisheries, and they use the digital twin for their filtration systems to understand how the water flows, how the machine is working, and if it has problem, and also how they can improve the product in the future based on the flow of the data in the digital twin. The other example, which is also from UK, is with the Genie. They manufacture building material lifters for construction industry, and they had a big issue with the painting of their products, and they had lots of warranty claims. So they used they connected their machines for painting, and they were able to find in real time if there was any improper painting or something was wrong, and they were able to improve the painting at their machines, and this helped them reduce the warranty claims, so they saved lots of money, but also they were able to improve the brand perception for their customers. Other example is with the edge computing, but I will also go to the last one, which is with Reliance about predictive maintenance. They manufacture machines that analyze that they process steel and aluminum, and they use predictive maintenance in order to reduce the downtime of their machines and reduce their costs. Because if one of these machines had a problem and was stopping, they were losing hundreds of thousands per day. So the business case was great. Speaking about the vision, I would say that what we see as a vision is today. First of all, today most of the customers or companies are looking to have visibility of their factory and of their machines in one factory. But the vision of many manufacturers, and AWS is helping this vision, is how to have enterprise level visibility of many different sites or production lines or factories, and have one central place to store your data, to analyze it, and create different metrics and KPIs from factories maybe across the world, or many different production lines. So this is something we are working with Volkswagen to create a digital production platform and achieve a 30% productivity. And you may wonder how it could be relevant to smaller players. I think it's interesting here to make the point that Volkswagen cannot achieve this their goal for a 30% productivity if their vendors, the SME suppliers, if they do not digitalize themselves, so they can participate at this digital production platform of Volkswagen. And similar concepts are discussed by other automotive companies or other multinational manufacturers. So even as supplier, SME supplier, I think it's important to think how to connect your products and provide the data to your customers. I have here one I think the most fascinating example around industrial, which is from Woodside. It's from Australia, and they are a LNG provider, liquefied natural gas. And they have these facilities which are very dangerous, full of chemicals. If something goes wrong, people can die. And these are usually in remote areas. And they have managed to bring all the technologies that we discussed today, to bring them in their facilities, like IoT sensors, video analytics, robotics, digital twins, augmented reality. And I have a video that I hope it will play. Here we can see like it's a digital twin from their facilities, full of pipes, and the pipes have also sensors to show in real time the status of the equipment, the temperature, the vibration. And there's also an autonomous robot that is capturing the video, and other people are watching it from very remote areas. They are not in the facilities. So instead of sending people to do the inspection, they send a robot, which is much safer and time efficient. Okay, I hope you got an idea about this exciting example. Some key takeaways to have in mind, I would say that don't think that all of these examples are very futuristic. Maybe 5 years ago was very difficult for companies who are not digital to implement them, but today AWS has built the tools as a managed service to help you or partners to help you achieve these goals and outcomes and use these technologies. Another, I think, takeaway is to remember that don't try to do everything at the same time in terms of digital. Try to select the number 1 or 2 use case that makes sense for your business, and focus on these 2 use cases and try to work on the proof of value, and then go to the other use cases. But if you do many things at the same time, it will be very difficult, and the experience has shown it doesn't work. And you may wonder, okay, AWS has these services, but how can manufacturers how can they be supported? We have the experts like solution architects who know these cloud technologies that they can advise you. So there's this support. We have, if you are in the ideation stage and you are thinking how to connect your products and what could be the business model or how to connect your factories, we have something like Iot Innovation Lab, where we invite the customer, like the CEO, the technical leaders, plus the partner to do it, so you can see what other companies are doing in your sector and prioritize maybe one use case. We have also the specialists like myself, also for AI, for machine learning, for analytics. And I think the most important is about the partners. We have a very strong network of industrial partners that can help you with implementing your plans, or help you with the hardware, help you with the connectivity. So try to reach out to us also, not only for cloud, but for the broader partner ecosystem we can bring. And we have also a local partner who is based in Cambridge, who are experts in factories and connected products. The name is Green Custard. And I think the timing is great. Just to say that last month, Green Custard, they introduced something very simple, some 3 kickstarting solutions that they have a very low cost, around 5 to 8Ks, for the most common use cases like condition monitoring or production monitoring, to implement it in a few weeks. And they use sensors, a cloud from AWS, and their people, their experts, to implement it. We saw in the market that it was very difficult for companies to decide how to start. So Green Custard made this offering to help small, medium manufacturers to start their journey. And I will pass the stage for a few seconds to Oliver, and then we're ready for questions. Thank you.
Perfect. Thanks, Demetrios. That was really, really good. If you want to reach out to us, our emails are there, or alternatively, you can just go to the Contact Us on Amazon Web Services homepage, and you'll get routed to one of the territory managers, whether that's either myself, Steph, or another of our, I think it's about 46 of us. Feel free to reach out either directly or through Contact Us. But I realise we don't have that much time, so I'll open the floor up to questions.
Yeah, here are also the emails, and also feel free to connect on LinkedIn. I'm using it actively, posting also news. Let's see what questions there are.
Okay, well, thank you very much, guys. That was a fascinating presentation, and certainly you taught me an awful lot about Amazon and AWS and things I just didn't even know that you were involved in. One thing that I really wanted to pick up on was the digital twin model. Here at Charpak, we're an SME, we're a well-established family business, and we manufacture one-way food packaging out of plastic. Now, that's not a fashionable thing to do at the moment, except that 3 or 4 years ago, we put in a localized circular economy. So our raw material is recycled material, and it's collected locally. So when you buy that nice piece of cheesecake from Waitrose, that is packaged in recycled material. Now, what the digital twin model has allowed us to do is be incredibly efficient at that. And so it allows us to prove that not only is it recycled plastic that is in turn fully recyclable, but it has 30% of the carbon footprint of making the equivalent cardboard package. And that's a huge thing for us. And it's enabled us to win a UKRI funded collaboration with Unilever and Veolia to further increase the availability of recycled materials. And that's all done through digitalization. It's made us a much, much better company. Now, I think the question I would like to ask, if I may, is just how AWS supports SMEs. We've seen a little bit about Green Custard, and that looks really good, and it's in our local area because we're in Huntingdon. How do we engage with you? How do we actually bring you in? How does a a 10 or 20 million pound turnover company deal with a leviathan like AWS?
Stephanie, you want to go first?
Yeah, I'm happy to take that. So that's exactly what Ollie and myself do. We're here really to help you navigate the AWS cloud, and we're here to support you through the best means that we can. Like Dimitrios mentioned, we have an extensive partner network that we can help you navigate, but we also have a set of internal specialists. But we also appreciate we have quite a lot of services. So we're here to be sort of a guiding hand and meet you where you need to be. So if you've got the internal expertise and you're looking to bounce ideas off a specialist solution architect, we can support. If you're looking for a consulting partner to help you with an undertake of a certain project, we're here to guide you to find the right fit partner for you. So if you've got a question, if you want to, talk to us and hear on how we can support you specifically on your use case, just reach out to us through the links that we've shared today. But it's really that simple. We're here to do that specifically.
Well, that's wonderful. Well, thank you very much for your contribution to the event today, all of you, Dimitrios, Stephanie, and Ollie. And thank you for helping out the STC. We really appreciate your support. So I'm going to crack straight on to our next guest. And this is Naeem Kapadia from the MTC. And I want to actually just preface this with just saying a little bit about the MTC, because at Charpac, the MTC are all over us at the moment. We were recommended to speak to the MTC by Warwick Manufacturing Group. We wanted to make our whole production facility better. We wanted to improve it in every way. And the result is that we are currently day to day engaged with the MTC. They're actually coming down and visiting us. It was daunting for our board of directors at first. But wow, we're so glad we did it. The MTC could not be more helpful, could not be more engaging, could not be more supportive. We're also, apart from this collaboration, we're talking to the MTC about helping them with other projects within the medical area, for instance, where they need our specialist thermoforming technology. So without any further rabbiting on from me, Naeem, would you like to carry on with your presentation, please?
Thank you, Niall. Thank you. So yeah, I hope you can see my screen. So good afternoon, everyone. Once again, thank you for allowing me to present the work that we've been doing at the MTC. For introduction, my name is Naeem Kapadia. I am the technology manager for the electronics team. I've been working for the MTC since 2012, developing capabilities in advanced production systems. I've also been involved and working in additive manufacturing, in particular in the electronics area. I've been responsible in leading the smart factory for electronics manufacturing using legacy equipment project. Now, prior to joining the MTC, I have over 25 years of experience in the electronics manufacturing sector, working in the contract manufacturing and PCB fabrication. I've participated in and led many programs in the UK, disseminating Montreal Protocol, the development of surface mount technology, and lead-free implementation. So I'm here today to share our work and journey around smart factory for electronics manufacturing. As Niall just mentioned around what we do, but just for the benefit for the rest, I would like to take a few moments and share a couple of slides of what we do at the MTC. So to give you a bit of background, Manufacturing Technology Centre, we're based in Coventry, that's our main site. We've also got a site in Liverpool and Oxford. We're fairly a young non-profit organisation, opened in 2011. We are an independent research technology organization. Our aim is to bridge the valley of death, which I'll explain in my next slides. And our goal is to help improve innovative manufacturing ideas by either working in collaboration or one-to-one. We offer other services, and such as developing and enhancing manufacturing system solutions by training and development. Our main founders are University of Birmingham, Loughborough University, and University of Nottingham, and also TWI, the Welding Institute. So bridging the valley of death, so we play a part in the TRL 4 to 6. So the universities play a part in the TRL 1 to 3, where some of the great ideas are explored. We call it the valley of death because some of these good ideas that universities or organizations have don't go further than TRL 4 due to constraints in funding or innovative support. So our remit is to work with these universities or organizations to explore these good ideas to de-risk, accelerate these programs through the TRL 4 to 6. So this is a bird's eye view of the MTC and the AMTC. So we have now more than 800 staff working between the sites. The building on the left is our apprentice academy. The building on the right is where we do the innovation work. We have another 2 large buildings at the back where we do more innovation work. Okay, so I'd like to briefly explain what is electronics manufacturing and where it is found. As we all know, PCBs are found in almost every electronics device, and with the increased demand for electronic devices all around the world, their production rate is increasing by the day. There are many small and big PCB manufacturers all over the world, including UK, all trying to provide quality services and customer satisfaction to stand out in the competition. However, the PCB services can differ in terms of quality and number, but they follow almost the same process building the PCB. So the image on the left is the illustration of a circuit board's manufacturing factory. However, our discussion today will be around the red circle, which is a surface mount technology. These machines run at phenomenal speed, placing components up to 180,000 components an hour. So in the UK, despite we are the 5th largest electronics manufacturers in the world, and according to the latest Reed Electronics Research Report, there are circa 250 electronics manufacturing services in the UK, generating around about £19.4 billion. Okay, so as we gathered in the previous slide, the electronics manufacturing is highly automated. Now, printed solder paste on PCB solder pads is the first step in the PCB assembly process. It is done by a solder paste printing press, which is located at the end of the production line to print solder paste or patch adhesive onto PCB solder pad to prepare the components for welding. Now, once the printed PCB has been confirmed to have the correct amount of solder paste applied, it moves into the next part of the manufacturing process, which is the component placement. Now, each component is picked from its packaging using either a vacuum or a gripper or nozzle, checked by the vision system and placed in the programming location at a high speed. There is a large variety of machines available for this process, and it depends greatly on the business to what type of machine is selected. So, for example, if the business is focused around large build quantities, then the placement rate will be important. However, if the focus is small batch, high mix, then flexibility will be more important. So after placement inspection, the next stage is the reflow soldering process. The soldering is a process which the solder as a sticky mixture of powdered solder and flux is used to temporarily attach one or several electrical components to their contact pads. Now, after which that entire assembly is subjected to controlled heat, which melts the solder and permanently connects the joint. Heating may be accomplished by passing the assembly through a reflow or under an infrared lamp by soldering individual joints. Okay. So this now takes us nicely of how our smart factory electronics was initiated. So to give you a bit of a background, the initiative of Smart Factory for electronics manufacturing started back in 2018. We carried out research using our internal major project route, which gives some fundings to go and explore capability in electronics. Now, we spent that money to take our first steps in the digital domain, looking into what was being done around I4O for electronics manufacturing. Now, we spoke with several companies, varying from OEMs, contract manufacturers, SMEs, non-SMEs, now, which included some of our members around adopting and viability of I4O electronics manufacturing. We then spoke to several members and partners from the technology provider's point of view to see what work they were doing. Now, we took our next steps by inviting members and partners into one room at the MTC. Now, you can see from the scrolling pictures we took on the day, we had a great response and attendance, and the day was packed with presentation and had more than 50 people attending. Now, one thing we were very clear and mindful with our objective is any solution that we find will be off-the-shelf solution, so they can work with us on this journey and support others in the future. MTC is open access environment, and we welcome all members, partners to bring their offerings and value propositions to make this a success. Now, we probably have the same industrial challenges that businesses currently face in other manufacturing areas. However, we have taken advantage using our facility and setup, which is like a mini factory and a true representation of an electronics factory. Now, the full-scale production line that we have at the MTC is worth around about 2.5 million, where some of the assets owned by the MTC and by some of our respectable members on the basis doing activities that industry cannot do. So therefore, doing the activities on site does not interfere with your day-to-day work, and it is an ideal test bed to de-risk and trial at the MTC before deploying it at your facility. It also gives the opportunity to collaborate with like-minded people, and it all allows us technical providers to showcase their hardware and software at the heart of the MTC. So when we first started our first project, we rearranged the lab and started our work in order to demonstrate the project. It is easy to show you a short video, which was done after the project was completed, and hopefully will give you an insight of what we did. Electronics production is one of the most complicated manufacturing processes, using multiple machines, putting down thousands of discrete components per hour at a phenomenal speed. The Smart Factory demonstration objective is to inspire, accelerate, and scale electronics production using legacy equipment for Industry 4.0. The testbed is to help UK PLC, but in terms of inspiring, we want to drive change, and we drive change through integrated manufacturing solutions. And that is the heart of what we do.
This is a solder paste inspection station. Normally, when a board passes, it'll proceed straight along the conveyor and through the rest of the production line. If a board fails inspection, the conveyor will instead raise it up off the conveyor and send a signal to the robot, which will then collect the board from the conveyor, move it over to be placed on this mobile platform, which will then take it over to the washing station.
Automatic optical inspection data sometimes requires operators to verify the result. To aid this process, augmented reality has been introduced to overlay the design file with the inspection report to quickly identify the areas of interest for the operator.
The Smart Factory for Electronics Manufacturing using the Legacy Machine project has allowed us to set the foundation and testbed for demonstrating three key areas: connecting legacy machines, vertically using a standard protocol called IPC-CFX, IPC, who are one of the largest trade associations in the world for electronics, augmented reality, mixed reality for capturing defects, use of Omron, collaborative robots and automation to minimize non-added value activities. We're about attracting, inspiring and demonstrating what we can do in industry to really drive impact. We are doubling down on some of the aspects on how we inspire, how we show people the art of the possible. So the work we've done today on this project has given us a great start of a journey and allowed us to set up this test bed. Now, this test bed is one of its kind that we can use to demonstrate i4O to the electronics manufacturers in the UK and all around the world. Now, after completing the phase one and after consultation with our members and partners, the phase two of the project was initiated, and the project was to look at 4 areas: cybersecurity for electronics manufacturing, AI for electronics, augmented reality for electronics, and getting the cobot to do multitask. So why did we look at cybersecurity? I know we've heard a few comments from our guest speakers today. Cybersecurity is an area of concern, especially when you're using legacy equipment. IT departments will do everything to stop any machine with old operating systems to be part of the network. Now, as part of the Smart Factory for Electronics Manufacturing, we were tasked with the goal of deploying an application suite called Clarity onto the EM network and demonstrating its capability. Now, software was installed on our server, and we have been able to detect assets on the network, start to inventory assets, and take a look at the vulnerabilities, risks, and insights. Now, when we connected the series of machines, we came across some issues where machines were on different subnets, different architectures. Now, this did not matter in its current form. However, by changing the subnet and IP caused further issues in responding. So we had to work with the machine vendors to get them all on the same subnet. From this, we have been able to determine clear benefits of using Clarity, even though we are faced with limitations. So work package 2 was to look at how the data we were collecting and can be used for AI. So on our phase 1, we were able to connect the machines and collect the data and listen to the machines and how they were performing. What we were not able to do is pre-process the data, split the data in a way that we can train the model. The AI team did some failure mode analysis and were able to predict some failures. However, there is more work that we need to do to validate some of the predictions. So in this work package, we took the augmented reality to another level from what you saw in the video. Our aim in this project was to demonstrate use of AR in doing maintenance work using the HoloLens. AR mixed reality is being considered to help with the pending retirement by 2026. It is estimated 20% of the workforce in electronics will retire, leaving a skill gap in the electronics industry. Now, with the younger generation, as we all know, the technology is at the forefront and it's like a second language to them. So AR VR will not be a surprise. So the mechanism will walk through a step-by-step guide to ensure consistent actions are carried out. Other benefits from this technology is that remote access could be carried out without going through troubleshooting with the machine vendor. And I'll show you an example which shows a filter being changed on the machine. So this is another work package we worked on. The cobot in the phase 1, we managed to get the robot to carry out one task. Now, as we all know, in the real world, the tasks of the robot is performing we won't expect too many rejects. Therefore, the cobot utilization will be low. So in this work package, the task was to look at the cobot performing multiple tasks depending where the request was coming from. So I've got a little video just basically showing a robot, a cobot on an AIV, an arm on an AIV rather than a fixed arm, performing the same tasks, going in here and picking the robot up. But if it is idle, it will go and pick a board or pick something up from a different location. So that was the task. We've got some more videos. We're hoping to, due to pandemic, we weren't able to get a professional video man in, but we've got a professional video coming in the next 4 or 5 weeks' time, hopefully, and we'll have some better videos for that. Okay. So what are we doing presently? So we've just started phase 3. So what we've done so far has been around OT, operational technology. Moreover, our focus is now going to start moving towards IT, information technology. So therefore, we have established 4 work packages. The first work package is to understand and establish a variable mapping tool for data flow from input to output. What I mean by that is I want someone from our digital transformation team to come into the electronics area and identify the gaps, although we're working with all these members and partners, where we need to put our focus on. The second is to set up and demonstrate an MES handshake between the OT and IT. Third is to set up and demonstrate a secure dashboard systems for electronics manufacturing. And the last but least is to extend the use cases for the cobot in our electronics environment. So the future around a smart factory electronics manufacturing is that there's still a lot of work to do and consider where we are now, where we want to be, and how are we going to get there in the future. In our opinion, the future and the vision for adopting factory of the future is think big, start small, and scale fast. Since the work we've been doing, we've been recognized demonstrating Europe's first smart factory for electronics using legacy equipment. We've put a timeline where we'll need to look at current skill sets and look at how we want to upskill people as we go through the journey. We want to in future have operators do the technician type of work. We want technicians to do the engineering type of work, and the next generation engineers to do work around cobots, AR programming, and so forth. Now, addition to the skill sets, we have a number of items like machine-to-machine integration, 5G, cobot, more cobot, prediction maintenance, all the way to become more autonomous factory programs that we would like to do and consider moving forward in the future to help the electronics industry. Now, in order to get people on board is embrace the vision. This can only be achieved by getting people involved and working as a team, getting the people curious, not concerned. People do get concerned with their jobs, job losses, but that's not the case. And transparency is the key for success. Hopefully, by demonstrating practical solutions, we'll show value to your organization and your customers. Thank you for listening, and happy to take any questions.
Well, thank you very much, Naim. That was very interesting, a fascinating case study of how the MTC works in the electronics industry there. And I can vouch for you that your methodology transfers to other industries. You know, we're making volume packaging. We make millions of simple parts a year, and you are transforming us. There is no doubt about it. One question I'd like to ask, as we move into a post-pandemic world, I first visited the MTC in Coventry about 3 years ago, but as we move into a post-pandemic world, how do people visit you? You've got a very impressive facility there.
So at the moment, I mean, we're still following the government guidelines in terms of how we should proceed. The factory is open. We're controlling and managing people as they go in the business. However, we are taking a different approach in terms of moving forward. There are discussions around hybrid working. There'll be a lot of hybrid working. So obviously you've got a workshop, and you need to have people around the workshop doing certain things, certain activities. But we've got a lot of desk space, a lot of engineers, and to be honest, they do want to have what we call collaboration spaces now, where without innovation, you need to collaborate. And sometimes doing it online isn't the best way of doing it. Touching and feeling is obviously is the key for us, and so they're looking at if you want to come into the MTC, as things open up, that we've got systems that you book a desk, you'll have collaborative spaces where you go in and you do your work, and then whatever you can do from home, and that's the approach I think we're seeing, and that's the approach we're looking to adopt, and hopefully we'll set an example for future manufacturing industries as well.
Yep. Well, thank you very much for that. And perhaps I should tell the audience as well that the MTC is extremely accessible. It's in Anstey Park, just off the M6, very close to the M69, very close to the M1. For me, from my home in Northampton, it takes 20 minutes to get there, and you do a damn fine cup of coffee in the cafe as well. So so my message to the audience is engage with Naeem and his colleagues. They are incredibly helpful. They're a not-for-profit organization. They are there to help you, and their facilities are out of this world. So thank you very much, Naeem.
Thank you for having me.
So I think unless anyone's got any more questions for Naeem, I'm going to say thank you very much, and call Pim back onto the stage for closing remarks and getting you onto the networking. I'm hoping that you'll have plenty of networking to do with your colleagues in the STC. I hope you've enjoyed the event today, and I look forward to seeing you face to face at the table shortly. So over to you, Pim.
Thank you very much, Niall. Much appreciated. So yeah, thank you very much. I just kind of want to wrap up with some housekeeping items, if you will. So as per usual, we've recorded the event, and we'll be sending you a follow-up email with the slides of all the presentations, and also the contact details of the various presenters and the various contacts if you want to do some follow-ups. It should include the recording of this event as well, so there should be lots of opportunity for you to sort of re-engage and get involved. Obviously, I'd like to thank all of our speakers. I think it's been a fascinating day, really interesting. Niall, obviously, thank you very much for comparing and hosting it. I think it's been really great. In terms of sort of our feedback on the event, we would love to hear from you on what you made of the event. So by all means, put some comments in the chat. If you're not keen on typing, please just put an A in the chat if you really enjoyed this event today. That's all good feedback for us. Obviously, by all means, let us know what else you would like to hear about, and I know that with follow-up email, we'll send you a little questionnaire where we ask that question as well. So please do tell us what you would like to hear more about, and what sort of events you're looking out for, so that we can put those on for you. So of course, we've got lots of other events coming up, so do please visit our website, silverstoneTechnologyCluster.com, where you can see all the upcoming events that we have. We also have quite a good library now of all of our past recordings of past events and webinars, so do please have a look at that as well on our YouTube channel. So yeah, with that, I think we can leave it there. We obviously have a networking facility, so we'll leave that open until about 1 o'clock. So please do, join the table and engage with the people, just like you would do in the real world. Because obviously we are looking at trying to bring back real life events, but obviously we need to do that in a safe and responsible manner. So we'll continue to follow government guidelines, but hopefully we're in a position that before too long we can get real life events going again, but hopefully also with a bit of a hybrid option, which we're exploring. So hopefully we can make all of that happen. So with that, thank you all very much. Enjoy the networking, and hopefully we'll see you at the next event. And for those watching this on YouTube, thanks for watching. Please like, share, and subscribe. and yeah, help us in that sort of manner. And obviously check out what else we have on offer. We would love to hear from you, and we'd love to be able to help you. So thank you very much, and goodbye.